So this lesson is a video on Heron's formula here. And so really when we're talking about this specific formula, it's really regarding, or it's really applicable for triangles that are scalene. Again, a scalene triangle is defined to be a triangle whose side lengths and angles are distinct, right? So there's no angle that is same. So all side lengths are different and all angles are different. So it's a scalene triangle. It's you primarily used for such triangles. So let me just give you an example. You may have a triangle, something like that. So A, B, C, right? And so this may be 18, this may be 12, and this may be 24. And you have this type of triangle here. And so you're finding the semi-perimeter, right? So I'll just go over the formula here that you should know. So A is equal to the square root of S times S minus A times S minus B times S minus C. So that's the formula. So it's A is equal to S times S minus A times S minus B times S minus C, and the entire value's square root, where S is the S is the semi-perimeter. It's the semi-perimeter of the triangle here, and obviously A, B, C are the lengths of your triangle. So that's the way how to compute the area of a triangle that is scalene, right? And obviously you don't have to use the law of sines, cosines really to determine the angles and then try to find the height, right? So it's like I had the case SAS that was used to find using the sine, right? That if you have SAS, you can do half times A times B and then sine of angle C, right? Similarly, this is a case where it's SSS. You have three sides that are given to you. Usually it's good if they are distinct. That's where it's primarily used, but I believe they can be there can be two sides that are equal as well. So looking at this, we can find the semi-perimeter, right? All we're doing is we're adding these three side lengths. So we do 24 plus 18 plus 12, and we divide this by 3, right? So that's just 54 divided by 54 divided by, I believe it should be 2 here, because it's the semi-perimeter, not 3. So that's a mistake here. I would just be 2, right? And it makes sense because it's semi. So always, what happens is that even I get confused sometimes when you're finding the semi-perimeter, but just what happens is when you're adding the side lengths, it seems like you're finding the average of those three side lengths, and that's why I tend to divide by 3. However, if you think about it, it's semi-perimeter, right? It's half of the perimeter. So whatever value you're getting after adding the three side lengths, just divide that value by 2. So that's why we have 54 divided by 2. So it's always going to be divided by 2, and that gives us 27. And to find the area now, we just plug this into the formula, right? So it's the square root of 27, right? Because that's S times S minus A, right? So it will be 27 minus 12, right? It would be so we have 27 here, so it would be 27 minus 12, and then we can really take anything, it doesn't matter, and then we have 27 minus 24, right? And times 27 minus 18. So you can see we're subtracting all three side lengths. We have 18, 24, 12. Doesn't matter which order you go into, right? And so if we further simplify this, it's the square root of 27 times 3 times 15 times 9, right? So it's a square root of 27 times 9, 27 times 9 times 3 times 15, right? That's what we have here. So we can further evaluate this and do its square root, and we see that the area of this triangle is 104.57 units square. So So that's our answer, 104.57 units square, using this formula here. And so again, this formula is again primarily used when you have that SSS, or you have all those three side lines that are given. Usually tends to be scalene triangle, but it's this formula that you wanna keep in mind. So thanks for watching.